Welcome to session 8 of the Lawson Fuses Fuse Masterclass. Today we're going to be looking at the Lawson Fuses datasheets. We'll look through the industrial bolted series purely because this is one of the most popular ranges we sell. It's called N and T type because most of the part numbers begin with N or a T. Bear in mind there are other datasheets available for different fuse types. The front page is now shown. This page shows us which fuse standards are referenced and which fuse system is being used. It tells you the range of the current ratings, in this case 2 amps to 800 amps. The breaking capacity is stated, in this case 80 kiloamps at 415 volts AC and 40 kiloamps at 250 volts DC. The breaking range and utilization category is shown as GG. Hopefully all of these terms will mean something to you now. The next lines are references to other data, labelled as SK something. SK just stands for sketch, another name for a drawing. The following SK numbers give a separate page for a range of details. We'll go through these one by one. On the screen now is SK 410. SK 410, 411, 412 and 413 are all dimensions of the wide range of fuse links available. There's a handy diagram to show the shape of each type. And if there are other options such as offset blades or fuse links with 2 holes in each tag, for example. In the tables below the diagram, the column headings show the following. BS88 reference. This is a dimensional reference to the standards. Your specification may require an industrial fuse link to A4 dimensions. This table will tell you which components are applicable. This means that from these tables, you can easily break down the characteristics of each component. So you can choose the correct fuse link for your applications. The column next to this is the component type. These are the numbers and letters you need to order from us with just the current rating after the letters. The next column is current ratings. This is the full list of current ratings that are available for that particular type of fuse link. Note the asterisks next to the current ratings show that these ratings are not in a standardised list of ratings. It's fine, they've all been tested and certified for use, but they may be handy if the rating you are looking for is not in the general standards list. The columns after this are all the actual dimensions, which refer to the diagram at the top of the page. Note some of these are listed as max or non values. Max just means the figure shown is a maximum value allowed. Nom stands for nominal. The nominal figure is a target figure, but there may be a little leeway due to manufacturing tolerances. SK414 is the graph showing the time current characteristics. Different colours are used for alternative curves, just to help read the correct curves when you are following it, along the various current ratings or times. The graph scales are both logarithmic, so the full graph can be shown on a single page. I will give a separate session later just to show how to read these graphs. Note that these plotted lines are from actual values, and so there is just a single line. The standards show a gate of high and low pass fill criteria, so there are 2 lines per rating. Between these lines is known as the current time zone. SK415 is just the same graph for motor rated parts. Remember, all motor rated parts are 2 current ratings separated by a capital M. SK416 shows the power dissipation or watts loss for each current rating. The units are in watts. The full bar is the max limit required by the standards, and the blue colouring in the bar shows the actual power dissipation on Lawson Fuses components. All manufacturers will have slightly different values. SK417 is the current carrying capability. This is a handy page if you were setting up an electrical system with a high ambient temperature. At ambient temperature of over 45 degrees C, you may need to derate some of the current ratings. Fuse links are a thermal device and will act slightly differently at higher ambient temperatures. For example, at 45 degrees C, a 630 amp fuse link will have a current carrying capability of 620 amps and will act as if it is a 620 amp fuse link. Note these figures are for components mounted in open air. If your fuse link is mounted in an enclosure, the ambient will be higher. If you're unsure of the internal enclosure temperature, assume it is 15 degrees higher than the external ambient temperature. There are some other handy examples on SK417. If you need to reference this sheet, have a read of the examples to make sure the layout of the table is clear to you. SK418 is a graph of the cutoff characteristics. Again, the scales are log values. This graph helps you calculate the current limiting capabilities of a fuse link. The applicable fuses are designed to interrupt fault current quickly, so limiting the peak current and reducing the energy let through to the protected circuit. This current limiting feature is crucial for protecting electrical systems from damage due to short circuits. I will be dedicating a future session to current limiting calculations. SK419 is a graph showing the I2T characteristics. The standards specify the limits you have to be between. This table shows the actual values of Lawson Fuses components. The axes are just the current values on the horizontal axis and the I2T value on the vertical axis. The coloured bar shows the value from the pre-arcing I2T to the operating I2T. The pre-arcing I2T is at the lower end of the bar. Lastly, SK420 shows a table and some handy hints to calculate the fuse link rating for use in a motor circuit. Again, I will be dedicating a session showing you how to calculate the correct fuse link rating. Okay, that's it now for a whistle-stop tour of the Lawson Fuses datasheets. It will lead to a few more sessions showing you how to read graphs and do a few calculations. I hope you found it interesting. Next session, I will be looking at how to read a current time graph. Don't forget to follow, share and comment. Thank you and bye.